There are quite a number of real life situations that require the application of polynomials. Engineers use polynomials to create buildings and structures. Businessmen use it to produce cost efficient products. Researchers use it to interpret their results by way of graphs. In grade 9, you have studied quadratic equations. Here, you will know more about polynomials and how the concept of a polynomial is applied in our daily lives. We are now in Unit 1 of Learning Package 3, and this unit discusses polynomials and polynomial equations. The following are the learning competencies of this unit. 1. Perform division of polynomials using long division and synthetic division. 2. Prove the remainder theorem, factor theorem, and rational root theorem. 3. Factor polynomials. And 4. Illustrate polynomial equations. Now let us first discuss polynomial function. And the objectives of this topic are: define the following term, polynomial, and polynomial function. 2. Identify whether a given expression is a polynomial or not. 3. Determine the degree of a polynomial, its leading coefficient, and the constant term. Rückruf. This is a German word which means recall. Now let's recall the definition of a function and a relation. So what is a function? A function is a relation in which no two ordered pairs have the same first element. Okay? Recall that a function can either be one to one or many to one, but not one to many. So therefore, for every x, there should only correspond one and only one value for y. Okay, so no two ordered pairs have the same first element. First element here refers to the x value. What is a relation? A relation is a pairing of the elements of two sets. It is also a set of ordered pairs. Now take note that every function is a relation. However, not every relation is a function. So if one to one and many to one points to a function, one to many implies a relation. Now what is a term? A term is an algebraic expression. A term is a constant or a number or a product of a constant and a variable or variables raised to a positive exponent. Okay? So a constant, a number may be considered a term in itself, or a term can be composed of a constant and a variable, say for example 2x, 3x, negative 4x, and so on. Or a term can be comprised of variables raised to a positive exponent. Now, the terms of an algebraic expression are separated by either a plus or a minus sign. So terms are being separated by either a plus or a minus sign. Now, what are the parts of a term? Say, for example, we have this term, negative 10x to the fourth. So the parts of a term are the sign, numerical coefficient, literal coefficient or the variable, and the exponent or the degree of the variable. Now let's look closely at the parts of this given term. So we have the term negative 10x raised to the fourth. So this negative sign here, so this is our sign. This negative 10, which is enclosed in this pink box, this refers to the numerical coefficient. So the numerical coefficient is the number with sign included that appears before the variable. So as you can see, negative 10 here is the number that appeared before the variable x. Okay. Now this x to the fourth, which is found inside the blue box, this is the literal coefficient. Okay. And this 4 is the degree or the power of this variable. So the variable and its power, in this case x raised to the fourth, the variable and the power comprise the literal coefficient. So the numerical coefficient is the number with sign included that appears before the variable, and the literal coefficient is comprised of the variable and its exponent or power. Now let's have another example. Say for example, we have this term, negative 10 x to the fourth y to the fifth. So our sign here is this negative sign. This is the sign. And this negative 10 enclosed in this pink box is our numerical coefficient. So the numerical coefficient here is negative 10. This one here enclosed in the blue box is our literal coefficient. Okay. Notice that we have two powers here, two exponents, 4 and 5. Therefore, to get the degree of this term, we will simply add these powers. So the degree here will be 4 plus 5, and that will be 9. So the degree of this term will be 9. Now let's have a look at these key points. A polynomial is an algebraic expression that is a sum of terms where each term contains only the variables with whole number exponents and integral coefficients. So a polynomial is an algebraic expression, okay, which is composed of a sum of terms. Okay, and each term contains variables having whole number as its exponents. Now, a polynomial in X is any expression of the form a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus so on and so forth plus a sub 1x plus a sub 0 with real coefficients. So this is your polynomial in x. So the variable that's being used here is x. Now, what are the conditions for a polynomial? First, there should be no variable in the denominator. Again, no variable must be found in the denominator. Now, this implies that no variable should have a negative exponent. Because say for example, you have x raised to negative 1, then that is equal to 1 over x. In which case, x will be in the denominator, which should not be the case because there should be no variable in the denominator. Next condition, no variable inside the radical sign. This implies that no variable should have fractional exponent. So the variable should only have whole number as its power. And no variable is raised to another variable. Now let's proceed with the next key point. A polynomial function is a function defined by p of x equals a sub n x raised to n plus a sub n minus 1 times x raised to n minus 1 plus so on and so forth plus a sub 1x plus a sub 0 where n is greater than or equal to 0 and a sub n minus 1, and so on up to a sub 0 are constants or numbers. Now, these numbers a sub n minus 1, and so on and so forth up to a sub 0 are called coefficients. Notice that these are found before the variable in each term of the polynomial function. So we call them the coefficients. Now, among these coefficients, a sub n is called the leading coefficient. Okay? So take note that the polynomial must be arranged in descending powers of the variable. So you have to arrange it in standard form. So from highest power of the variable up to the lowest power. And then after arranging, you can now get the leading coefficient. Next, a sub n x raised to n is the leading term. So the leading term is the first term that appears after arranging your polynomial function in standard form or in descending powers of the variable. So you get the leading term. From the leading term, you can get the leading coefficient. And a sub 0 is the constant term. Constant or the number. Now let's have a closer look at this polynomial function. So we have p of x. So polynomial function in x is equal to a sub n x raised to n plus a sub n minus 1 times x raised to n minus 1 plus so on and so forth plus a sub 1 x plus a sub 0. Now, this a sub n is our leading coefficient. Take note that you have to arrange the polynomial function first in standard form or in descending powers of the variable. So from the highest power down to the lowest power of the variable and down to the constant, if there's a constant that exists. So in this example, in this polynomial function, this a sub n is our leading coefficient. Now that leading coefficient is found in the leading term. So the leading term here is a sub n times x raised to n. That is the leading term. And this a sub 0 here is our constant term. And these numbers, a sub n minus 1, so on and so forth, up to a sub 1 are called coefficients. Now let's take a look. Let's take a look at some more key points. So we say that a polynomial is monic if its leading coefficient is 1. The degree of a polynomial in x is the highest power of x in its expression. So that is how you get the degree of a polynomial. It's the highest power of x in its expression. A non-zero constant polynomial has a degree of 0. In other words, the degree of a constant is 0. So the degree of 8 is 0, the degree of 10 is 0, degree of 100 is 0. The degree of a constant is 0. Then we have linear, quadratic, cubic, quartic, and quintic polynomials are of degree 1, 2, 3, 4, and 5 respectively. So we all know that if it's linear, the degree is 1. If it's quadratic, the degree is of that function is 2. Cubic, 3, and so on and so forth. Now, p of x equals 0 is a zero polynomial. What do we mean by a zero polynomial? A zero polynomial is a polynomial whose coefficients are all equal to 0. Examples of this are p of x equals 0x plus 0. As you can see, the coefficient here is 0. Or we may also have p of x equals 0x squared plus 0x plus 0. Again, all the coefficients here are 0. 0 in x squared, 0 in x. Or p of x equals 0x to the fourth plus 0x cubed plus 0x squared plus 0x plus 0. This is another example of a zero polynomial. Now, what is the degree of a zero polynomial? The degree of a zero polynomial is undefined, whereas the degree of a constant is 0. So now, let's put what you've learned so far to test. So let's have this drill. Which expression defines a polynomial function? Explain why or why not. Number 1, 3 over x to the fourth plus 3 over x cubed minus 1 over x squared plus 2 over x. Is this a polynomial function or not? Explain. Number 2, x to the fifth minus 3x minus 10. Number 3, x raised to 2 thirds plus 3x raised to negative 1 plus 1. And number 4, 3x to the fourth plus 5 times square root of 3x plus 2x. Now let's try this next set of exercises. So state the degree, the leading coefficient, and the constant term of the following. Number 1, 8x to the sixth minus x to the fourth over 2 plus the quantity negative x squared minus 3x minus 1/4. So what's the degree, the leading coefficient, and the constant term of this expression? Number 2, x to the fifth minus 3x minus 10. And number 3, 8 minus x to the seventh plus 3x to the fifth plus 11x. And number 4, 5x minus 10x times the quantity 9 plus 2x squared plus 4x to the fourth minus 3x to the sixth. This ends our topic on polynomial function. Now let's take a break as you answer the exercises provided for you on this topic.